Hi, Niels.
Hi, Alexi.
Long time no see.
Yeah, it's been a few hours.
So, what do you want to show us today?
So today I'm excited to share with you a project that I've been working on called Pandera. It's maybe 2, 3 years in the making. It's basically a data validation library for DataFrames. Um, so it's fairly specific, but also because the notion of DataFrames is sort of evolving. It's the scope is sort of expanding slowly but surely.
Okay. Pandas data frames or in general data frames?
So it started off as a pandas only data validation library, but actually I released the 0.8.0 version last week, and it basically adds support for Dask and Modin and Koalas data frames.
So, but the name Pandera comes from pandas, doesn't it?
Yeah, that's right. Yeah, the funny story there is I used to play World of Warcraft, and Pandaria is a race of pandas in that world. So I'm glad that I misremember that name, so since there are no like copyright issues there. But I remembered it as Pandera, and so that's what I called it.
That's an interesting story. So, can you show us that?
Yeah. So I prepared a short demo, and I can show you. I can just point to various documentation for all the other features because it's fairly feature rich at this point. Can you see my
If you can
VS
enlarge
Code
it a little bit, that would be better.
here?
Yes.
Is this better?
Yeah.
Okay, great. So let me just jump to the documentation first. So like the way I've sort of framed Pandera is in terms of a statistical data frame testing tool. And statistical, I'm playing around with this idea of statistical typing as a kind of type annotation that relies on not just the data types, but you kind of have to inspect the contents of the data as well to get certain statistics to be able to say whether the data is valid or not. Um, and so this is sort of a reframing, and it's nothing new really, but it's an interesting way of thinking about it because data types and their contents and the statistics about them kind of generalize. It's very broad, and so you can apply it to many different things. Um, but the main features of Pandera are that the core feature is you can basically define data types for data frames. And I can jump into my editor now. So if I
Why
import,
do we need data types for data frames? Don't we already have like this D type in pandas, which is always like float or object, right?
oh yeah, I mean, well, it's fairly rich, right? There's like date times and intervals and strings and nullable strings and nullable boolean. So at least in pandas, the data types are not at all straightforward. And um, in terms of if I'm working with new data or data that's coming in from some external source, pandas might parse a certain column that's supposed to be an integer into an object
Because there's a
because
space or something like that, right?
yeah, there's like a question mark
Uh-huh.
or there's missing data. So unless you know beforehand what that data format is and how nulls, for example, are encoded, um, then like pandas will try its best to parse like the CSV file or whatever. Um, and it'll fall back to certain default behavior that if you don't explicitly specify the types, it'll bite you later in your analysis.
Yeah, that's my
Um,
experience with pandas. They bite.
yeah, that's yeah. The so I guess I should say the problem. the problem this really tries to solve is fairly close to the data scientist or data engineer or machine learning engineer. It's kind of similar in spirit to data classes and Pydantic, if you're familiar with those. So you'll see in the syntax later that it's really meant to be for the analyst who's in the weeds writing code and has been bitten enough to spend maybe 5 to 10 minutes like inspecting the data and then going back and defining a schema so that when during the iterative process, you're rerunning your analysis maybe hundreds of times. So that upfront investment will just make you feel safer as you're doing the analysis. And that's really the itch that I was scratching for myself. So I built this sort of as a side project on my spare time, but really it came out of this problem that I had in industry doing analyses every day on diverse data sources.
Yeah, nice.
So Pandera has two flavors. The kind of the OG flavor, I would say, is the object-based API. So the way you define a schema, I designed it to kind of look like how you define a data frame. So you have this data frame schema object, and you give it a dictionary of keys to values, where the keys are the column names, and the values are this column object that then comes with a whole suite of useful arguments for you to define your types. So at the very baseline, you could just specify the types like so, and that's just the first argument. So, this is the repr of this object, and you can kind of inspect the other things that come with it that I won't dive into too deeply. But the second main thing that Pandera offers is this check abstraction. And this is really meant to be a super lightweight way to express validation rules. So these are built in: greater or equal to, less than, and equal to. And these are all just unary functions. Take a single argument, and it'll check each corresponding column for those properties. However, I could write, and again, this is super easy to extend, but let me just write this lambda function that takes in a series as input. And now I have access to the Pandas API. And the contract that Pandera establishes is, as long as the output of this function is a Boolean or Boolean series, Pandera will understand it and know how to report, okay, these are the failure cases. So if the output of this will be index aligned with the original data frame, right? So Pandera will know, okay, I'm looking at the int column. I have access to the series object now, and I can do whatever check I want, as long as it returns the bool series or Boolean, if you're doing some kind of like reduction, like if I just want to check if the mean is greater, or if the mean has a certain property. So that's really the core design of Pandera, is for the engineer or analyst who's in the weeds. Like, I don't really want to define another class or do like any fancy ceremony to like add a new custom check. This is, whatever framework you're using, in this case, Pandas. If I know Pandas well, I know how to define that validation rule. So then the second flavor, which is the newer flavor that I'm very happy to say was pretty much built from the ground up by Jeff Zank, who is one of the main core maintainers of the library also. He basically was like, hey, I want Pydantic-style schema definitions. And I was like, okay, go ahead. And we kind of went back and forth on the design, but this is basically what it looks like. This is the equivalent schema. And it exposes this to schema method. And yeah, the class-based API, you can see that it's the same exact object, or it's an equivalent object. And it's like Pydantic in that you basically have to inherit from this SchemaModel class. And all the class attributes are the column names, the column keys, and the type annotation is, you have to say series. This also supports indexes, so I can do something like this if I have an integer index.
This is pandas index, right?
Yeah, this is pandas index. And we have this field. This is a function, actually. It looks like a class, but it's a function that allows you to define the built-in checks. The way you define custom checks in this is by defining a method. There's a class method automatically, and it expects the series and to output a series or a Boolean, as I said earlier. And then, so again, this is like, if you're a user of Pydantic, this should be fairly intuitive. So those are the two main flavors. And now I'll show you kind of, these two things in action. So I'm going to define a data frame. And this should be valid. I've kind of set it up to be a valid data frame. And Pandera it's a validation library that sort of is meant to integrate well with your workflow. So, there are other ways of doing validation. There's a way that like this outputs like some kind of report with all the errors and stuff. But I kind of didn't want to do that here. And the way I designed it is if the data frame passes the schema checks, it should just return the data frame. If there are errors on the other, and then I'll use the class-based the schema model, and it's the same thing. Now let's corrupt the data frame. I'm going to copy it and add a bunch of values that I know will raise an error. So now we have this corrupt data frame. And I'll just use the schema model object here to validate it. And here I get an error. And so it kind of blows up in your face. This is not great because it'll error out as soon as it comes up against a column that's invalid. So in this case, it says schema column int call of this data type failed this validator greater than or equal to, and here are all the failure cases and all the indexes associated with it. This itself is a data frame actually underneath, and you can access it with a try except block. Now, if I want something a little bit better in terms of the use case of I want to know all the errors that you could possibly collect, then you can pass in lazy equals true. And then I get a different error now. So it says a total of 3 schema errors were found. And these are the 3 different columns for which there were errors. These are the specific, failure case values. And now, okay, this is cool. This is a nice summary. But during the debugging process, I want to know actually, like, I want granular access to all this stuff. So actually, I can actually catch this exception and access this failure cases attribute. I'm going to actually assign it to a thing, so a variable, so I can just inspect it later. So now this failure cases data frame has a complete, it's sort of like, the tidy data format where each row is an error. and each column is metadata associated with the column, the check, the failure case that was specific to that check, and the index where that check failed in the original data frame. So, this, you can set this, so, so if your entire data frame is failing, and if your data is big, this failure cases data frame might be very large. So there is a way to toggle it to only report on, the first n failure cases it finds per check. And, so this is really the core functionality of Pandera. The little syntactic sugar here is I can actually define functions with types. And as long as I import this data frame class, so this inherits from the pandas data frame, but it gives you, it's a generic type where you can feed in the schema. This will actually now validate the input and maybe also the output. Let's just say if it's the same thing and we're just returning the same data frame. So if I call this function on the original data frame, it passes, it's happy. And if I pass in the corrupt data frame, it errors out. And then, of course, here I say lazy equals true to do the lazy validation.
That's
so yeah.
I'm just curious, if I modify the data frame now, will it create a new schema for me, or I have to manually kind of like I have this function that I know I get this data frame in, and then I remove one column, I do something with another. Is it smart enough to actually figure out what happened?
Wait, is your question about how do I get a schema out of an existing data frame that I know is valid?
No, like it's more like schema lineage. So you have an existing data frame, so you modified it, it's passing, and then you do something with that data frame.
Yeah. So that's a great question. So let's say this function is meant to create a new column. Let's just call it foo, and let's just give it all values of 1. And let's give it the valid data frame. So this should pass because the schema is not strict. We could say that's another option, like extra columns in there shouldn't be there. But for now, this is like, okay, it has everything I expect, and there's this extra thing here that's foo, and so if we go back to our schema definition, we can configure it to be strict equals true. And I hope, I didn't test this earlier, but I hope this doesn't blow up in my face. Okay, great. So now it's saying there's a failure case, there's a column in the schema that was not defined. So what we can do here, the power of the class-based API is I can now define a new schema that inherits from the other schema, and it inherits all the properties. And now I can give it this, and let's just be super specific about this. Everything has to equal 1. And now I say schema out. And now it's happy. You can even do joins. So if you have another schema here, so that functionality isn't super well tested yet. So if there are like overlapping columns, I'm not sure what the kind of inheritance rules will say about that. But if you have another schema, that this will represent the join of those 2 data frames. So you can also do this with the object-based schema. There's such a thing as schema transformations, which is the benefit of the object-based schema, where you can delete and add columns, and
Because I guess in this case, my follow-up question was probably a tricky one. Like, what happens if you remove a column? Then you cannot really extend the class, right?
Yeah. So this is the class-based API only allows for additive transformations.
Yeah, that's pretty cool.
Yeah, and so maybe one last thing to note here is I can alias this to be something like a regex, and I can say regex equals true. And now this is just a key. This doesn't refer to the column anymore. It's the alias that refers to the column. So let me step back. If I don't say regex equals true, and I say something, this will be the column it'll check. But there's this use case where you have a group of columns that are semantically the same, and you want to apply the same validations to them. So this allows you to, I don't know what, I forget, regex is always, I need to look it up, but if there's a digit here, this will check all the columns that match this expression. And then finally, as I said, the scope of Pandera has expanded. So the current different types of data frame frameworks that it supports are Dask. Fugue isn't exactly a data frame framework. It lets you distribute the compute over arbitrary data, so the supported data frames that they have.
So many frames. Like
Yeah,
I heard about Dask, but not about like a Koalas maybe once, but the rest.
Yeah. So the syntax is exactly the same. So you define a schema once, and it should work for all of these supported ones. And so yeah, this is exciting. There are so many data frames out there, and I guess the direction the project is going is we'll just by request add more and more support, with various caveats depending on what built-in checks are and aren't supported.
I know in Spark DataFrames you already have schema. It's quite similar, right? To some extent.
Yes. Yes. Yeah, Spark schemas are similar. PyArrow schemas are similar as well. And I guess so. I guess the goal of this project now really is to just to integrate with the ecosystem and interoperate as best as possible.
You said there is one more contributor, Jeff. Are there other people? How many people are working on this?
In terms of core contributors, it's Jeff and myself. There was another contributor, Nigel Markey, who built out a lot of the initial documentation and a bunch of useful features. He hasn't contributed recently, but he's still, considered, one of the core maintainers, or maybe core authors. And at this point, there are 40 unique contributors. And of course, with open source, it's sort of like a long tail. So yeah.
If somebody wants to also contribute and join this long tail, how can they do this? Or maybe the head of the distribution as well. So how do they go about that?
Yeah, so the issues on the Pandera repo are numerous. Many of them are honestly for myself because they're fairly complex and go deep into the guts of the project. But there's a contributing page in the documentation. It just gives you some instructions on environment setup and things like that. And yeah, the issues page has many things that one can tackle. There's a good first issue label here for anyone who wants to get started. One avenue for contributions that I want to broadcast more clearly is these sort of Google Colab binder examples that let newcomers sort of give Pandera a try without having to set anything up locally. And so this, I've been wanting to do it, but like, I think this would be a good way for new contributors to try out the library, get in touch with me, figure out what kinds of examples make sense, and add them to the documentation. There is no recipe section yet, but this is sort of the direction I want to go with that.
What's SciPy 2021? This label that most of the issues have.
Oh yeah, these are all labels for the SciPy conference.
You gave a talk about that.
Yeah, I gave a talk and then posted a sprint.
So how can people watch the talk?
Let's see. I need to add this actually.
You can just send me the link.
I'll send you the link. But yeah, I've given a few talks at this point, and they're fairly non-redundant. There's some redundant aspects, but I've talked at PyData and PyCon and SciPy about this library, like different facets of it, and I can give you the links to all those presentations, and yeah, that would be great for people to check out.
So maybe last thing before we wrap up, do you have any advice for anyone who is watching this?
Let's see.
Use types?
Yeah, types. I mean, I don't know. Like, I don't really keep track of like what's like the trend or what the popular opinion on typing is, but for my personal experience, it's just amazing. I haven't used strongly typed languages too much, to be honest. And Python, like, you add types, and if you're not using MyPy, it's sort of like still the Wild West. You could give it whatever. But using MyPy or any similar static linting, type linting tools, with things like type guard, like things that actually enforce them at runtime, they just make life so nice when things are working and you want them to be reliably working.
I don't remember in the last video, did you also give this advice, or was it a different one?
It was more general around tools,
Okay.
like tools around machine learning. Yeah.
Typing was, I think you mentioned typing at some point as well, right?
Yeah.
So
yeah.
in Flight, you also like types, right?
Yeah. So Flight, it's sort of birds of a feather, right? Because Flight is strongly typed. Pandera is a DataFrame, as an attempt at adding type annotations for DataFrames. I think it's sort of like a common saying among people who like types. If there are no types, you're emulating a type engine in your brain. So, be kind to your brain and write them out explicitly. Like instead of having, is this a numpy array? It could be but it could also be pandas. So to disambiguate those things, and it's fine, right? Like Python is powerful because of the duck typing paradigm. But I think maybe I'm realizing, and maybe people are realizing, as Python is being used in production more, maybe this emulation of a type engine is not great for people who have to put out fires.
Okay. Yeah, thanks a lot. Thanks for joining us today. Thanks for sharing the demo and the project you're working on. And yeah, thanks.
All right. Thanks, Alexei. Take care.